Solve the equation, the square root of 7 minus x plus 5 is equal to x. Here we want to isolate x by itself on one side. In order to do that, we're going to need to get rid of this radical. So let's start by subtracting 5 from both sides and writing this equation as the square root of 7 minus x is equal to x minus 5. Now, we'll eliminate this radical by squaring both sides of the equation. The square root of 7 minus x quantity squared is equal to 7 minus x. And as we square this binomial on the right, remember to FOIL things out. This is going to give x times x, or x squared, minus 2 times our inner and outer products. So that's minus 2 times 5x, or a minus 10x, and plus that last term squared. 5 squared is 25. Here we have a quadratic equation. Let's put it in standard form. I'm going to move everything to the right-hand side, set that equal to 0 on the left. So we've got an x squared. Add x to both sides. Negative 10 plus x is a negative 9x. Subtract 7 from both sides. 25 minus that 7 is a positive 18. Now let's factor. This trinomial, if it factors, we'll factor as two binomials. Leading values must be x times x to give x squared. Factors of positive 18 that sum to negative 9 are a minus 6 and a minus 3. So we have the product of two things equals 0. That means one or the other is 0 or both. So use your zero factor property now. X minus 6 is equal to 0, or x minus 3 is equal to 0. X is equal to 6, or x is equal to 3. Now as we solve these equations with radicals in them, and we have to use our power rule like squaring both sides, be sure to check all of your proposed solutions. So let's check x equals 6. Make sure that you go back to that original equation, substitute 6 for x. Is the square root of 7 minus, in place of x we'll put 6, plus 5 equal to 6. That's the square root of 1, or 1 plus 5. Is that equal to 6? Sure is. That's a true statement. 6 is indeed a solution. Let's also check x equal 3. Substitute that into the original equation. Is the square root of 7 minus 3 plus 5 equal to 3? That's the square root of 4, or 2 plus 5 equal 3. Nope, sure doesn't. That's a false statement. 3 is an extraneous solution. It does not work in the original equation. Exclude it from your solution set. Let's finally summarize this by saying the solution set is the number 6.